Oh, hello. Let's do some more examples. D by dx of x to the 10th plus 4x to the 7th plus 3. Remember, the derivative of the sum is the sum of the derivatives. So you just do the derivative of x to the 10th. That's 10x to the 9. Remember, you bring the 10 down, and then in the exponent you fall down one notch to 9. And the 4x to the 7, remember the 7 comes down multiplicatively with that 4. You could say 7 times 4 or 4 times 7. And then remember that after that 7 falls down to a 6. And then remember, any constant, if you do the derivative of an additive constant, it vanishes. That plus 3 just dies. It goes to 0. So that's gone. So you just have these two terms. And then 7 times 4 is 28 there. And that's all I did on that next step. And for the quiz, I'll leave it for you to do this. Now let's look at this example. You bring down the 8. You cut 8 down to 7. Now be careful on this one. This plus sign is, we have a plus sign for now, but then now you bring down negative 8, that's going to turn that into a minus. So we get minus 8. Now remember, negative 8 falls down one notch. You fall down to negative 9. You're falling in the negative direction. And then negative 4. Now this was a negative, but this negative 4 is going to come down and hit this negative and give you a plus sign right here. So plus 4, and then the negative 4 falls down to negative 5. And then, by the way, I do one more step. If you want to write it in, notice that, well, there's one thing I forgot. Let me do that. Notice that you can write this as 8x to the 7, which we don't mess with, then minus 8 over x to the 9, plus 4 over x to the 5th, if you want to write it in positive exponent form from algebra. Sometimes your professor will let you stop here, other times he or she will not do that. So, and for the quiz, do this one. And again, now that constant vanishes. Negative 2 just gets killed, right? So, in the derivative. Okay, now let's go down here. Now, the derivative of 1 over x, that's the derivative of x to the negative 1 power, definition. Now, so the negative 1 comes down, and you get negative 1, and then you fall down to negative 2 up here. But that's understood to be, negative 1 in front's just understood minus sign, so it's minus x to the neg 2, so it's negative 1 over x squared, okay? So now d by dx of negative 1 over x, you remember negatives, you can just yank them out if they're multiplicative. So that's just the negative derivative of, now 1 over x is x to the negative 1. And then, now, remember, negative 1 comes out in front, but it's going to hit this negative right here and become positive 1. So we get positive 1x to the negative 2, which is just x to the negative 2 itself, which is 1 over x squared. And likewise, if you have a 6 up top instead of a 1, you just stick a 6 in front, and then that negative 1 is going to jump and multiply into that 6 and make it negative 6. You'll get negative 6x to the negative 2, and that's the negative of 6 over x squared. You could put the negative up here, but anyway, I just left it out to the side. And if you do a negative 6 over x, that's going to put a negative 6 initially out in front, but then this negative 1 is going to jump and bump multiplicatively into this negative 6 and get positive 6 there. So we get positive 6x to the negative 2, which is just 6 over x squared. Okay, and for a quiz, I'll leave it for you to do this one. Okay. And here, now this is the derivative of 5 over x to the 7. That's 5 times the derivative of just 1 over x to the 7. I just yanked out the 5, multiplicative. So that's 5 times, now 1 over x 7, it's better, we need x to the negative 7 format. 1 over x to the 7 is the same as x to the negative 7. Now remember, you yank the negative 7 multiplicatively out in front of the 5, and then the exponent falls down to negative 8. And then 5 times the negative 7 is negative 35. So we get negative 35 x to the negative 8 power. And so that's going to be the negative of 35 over x to the 8. And then in a similar fashion, if you got a negative out in front here, you'll have you can take out negative 5, the negative with the 5. And then you'll wind up with negative 5 times negative 7, which is positive 35 out in front. So you'll have a positive 35 over x to the 8. But anyway, just watch out for your minus signs there. And so I'll leave it for you. Here's a quiz problem for you to do. Now, guys, the derivative, remember, of any dummy constant is 0 by the constant rule. The derivative of any constant times x is just that constant. The derivative of a constant times the sine is just going to be that constant times the cosine by the yank out rule right here. Remember, the derivative of the sine is a cosine by the rules. We've actually proved that, but we'll just take it on faith from the rules. And notice I didn't put a time sign. Really, it might be less messy. It's okay. You might as well get used to 5 cosine x. What that really means is 5 times cosine. But anyway, the derivative of negative 5 times the sine of x, again, you could have this time sign here. That's just negative 5. Here's a time sign. D by dx of sine x. And that's just negative 5 times cosine x. And the derivative of any constant times e to the x is just the term itself. The derivative of 5 e to the x, yank out the 5, and you get 5 times the derivative of e to the x. That's 5 times e to the x. Notice we didn't change. So the derivative of any constant times e to the x is itself. The derivative of 5ex is 5e to the x. And, well, let's see. Now, if I would have had the negative out in front, like the derivative of negative, if I just had negative out in front, it would be itself. But the negative is not out in front of the e, it's up here with the x. That's a little different, guys. Here's the chain rule. What you got to do is you let u equal negative x from the get-go. So you do d by du of e to the u times d by dx of my u, which is negative x. And then, let's see. Now, d by du is e to the u. Now, d by dx of negative x is negative 1. But now, e to the u times negative 1, that's just negative e to the u, the negative of e to the u. Notice that negative is not being raised to the u power. That's negative 1. That's understood to be negative 1 times e to the u. But now you've got to go back and get honest and replace u. What is u? It's negative x. So it's negative e to the negative x, or you can write that as negative 1 over e to the x by definition. This negative right here just goes out in front. This little bitty negative up here means exponent, or reciprocal, I should say. Excuse me, reciprocal. Okay, now what if we don't put the 3 in front? What if we put the 3 up here? Then, again, we let u equal 3x. And so we do d by du of e to the u times d by dx of 3x. And so that's going to be e to the u times 3. And so that's 3e to the u. And that's 3e to the 3x. Okay. Now notice this negative sign up here. These little negatives were understood to be negative 1. One negative is understood, but now 3 we wrote out explicitly. And d by dx of e to the negative 3x. Let u equal negative 3x and go through the same motions. You do this, you do this. This time you'll get negative 3 here. So it's negative 3e to the u. That's negative 3e to the negative 3x. And you could write that as the negative of 3 over e to the 3x. But I didn't bother. Okay. And you can do this one in a similar fashion. Now, what I'm going to do both. I'm going to put now let's say I put a negative 7 here and a negative 3 here. The negative 7 is just it's just a yank out. You do negative 7 times the chain rule. The negative 7, we're going to leave him out in the code until the end. So you do the chain rule here like before. So you get negative 7 times. Now, by associativity, I can just drop those brackets. E to the u times negative 3. And that's going to be, now negative 7 times negative 3 is positive 21. And we get times e to the u. But you got to replace u. You always need to replace u back in terms of x when you're done, guys, okay? So you get 21 e to the negative 3x. And what else? And if you stick an understood negative 1 in front, which is just a minus sign, you yank out negative 1 and keep it out in the code until the very end. And you'll just get 3e to the negative 3x. And this time I actually went all the way and wrote it as 3 over e to the 3x. But anyway, and we let u be the appropriate. Now this time my u is neg 3x. I'm actually wrong there. Sorry. So it's negative 3x. I don't think I messed up anywhere else though. And yep, I messed up here too. U should be negative 3x. Sorry about that, guys. Oops. U is neg 3x there. Yikes. But no, that was... after that, I'm good. Yep. That's good. Okay, everything else is good to go. And oops. So I'll save that so it won't be messed up later when I have to close it. But anyway, moving on. D by dx of 11e to the negative 1x. That's understood negative 1 times x up here. So that's, yank out the 11, do the chain rule. You'll get the negative 1, and you'll get negative 11e to the u, negative 11e to the negative x, because remember, u is negative x up here. Okay. Now, so there's that. Now, guys, let me go back and explain something even from the very get-go. Like back up here, e to the u, I let u equal negative 4x. Here's the composition. G of x is negative 4x. F of x is e to the x, and I'm doing F compose g of x. That's what's going on here. F of x is e to the x, so F of u is e to the u, and I'm letting u be negative 4x. Okay. But it's tricky, but you're going to have to that's just something you have to get used to from algebra. Composition. Okay, and if you have a constant out, a multiplier constant out in front, you can just yank it out like that. Okay. And then in negative 11, you go through in a similar fashion, you'll end up with 11 e to the negative x. And then you can bring that e to the x down like I did here and like I did here. Okay. So there's that. And you do these for a quiz. Okay. And now the derivative of the sinh, I already let you take it for granted that it's a cosh, but I wanted to do a proof, so to speak. So that's just d by dx of, well, now the proof is going to depend on us knowing what the derivative of e to the x and e to the negative x are, but let's just say let's just take it for granted that d by dx of e to the x is itself e to the x, and d by dx of e to the negative x is, well, very shown by the chain rule, that's negative 1 times e to the negative x. So we do d by dx of this. You can yank out that 1/2 and get this. And then distribute through, and you get 1/2 times this minus 1/2 times this. I'm not derivated yet. Now we derivate. If I derivate e to the x, I get e to the x. If I derivate e to the negative x with respect, and I really want to say derivate, I'm being a little hollow. I'm derivating with respect to x. But if I derivate with respect e to the negative x with respect to x, I get negative 1 times e to the negative x, but that negative 1 is going to multiplicatively bump into this negative 1/2, and I get positive half here. So this is a plus sign after all right here. And then, so I get 1/2 e to the x plus 1/2 e to the negative x. But by algebra, that's just e to the x plus e to the negative x over 2. But we recognize that as the cosh. And I'll leave it for you to go the other way and show the derivative of the cosh as the sinh. It's a sinh, right? But anyway, moving on. I'm just kidding. D by dx of x is 1. D by dx of x squared is 2x. D by dx of x cubed is 3x squared. Notice there's a pattern. D by dx of x4 is 4x cubed. So what's happening is, like, the exponent's coming down, and we've already talked about this. The exponent's coming down, and we're subtracting 1 when we go to the new one. So, like, x squared turns into 2x to the 1. X cubed turns into, the 3 comes down at 3x squared. Come down and decrement, okay? The 4 comes down, and then what's up here turns into a 3, and we get 4x cubed. After we derivate, though. These are not the same thing. It's just 3x squared is the derivative of x cubed relative to x. But anyway, I'll leave it for you to do this one, okay? And, hey, guys, we can use irrational stuff like d by dx of x to the pi. That's pi x to the pi minus 1. And d by dx of, now what if there's already pi out in front? You remember, pi is just a constant. You can yank it out, and that's just going to be pi times this guy right here, which is pi squared times my x to the pi minus 1. You just do associativity. That pi and pi are going to bump into each other and make pi squared. So pi squared x to the pi minus 1. And if you stick a pi squared out in front, you'll just do pi squared times this guy. If you stick pi squared out in front, you'll get that, and so on and so forth for pi cubed. And I'll leave it for you to do these, okay? Now, if you notice here, I replaced pi with e. You just use e instead of pi. E is Euler's constant, approximately 2.71828. Okay. Now d by dx of 1 over pi, that's d by dx of x to the negative pi. Negative pi comes out in front, and up here you get negative pi minus 1. You can really stop here, But if you want to do some algebra, you can take that negative out and you get this. And then lo and behold, but this gives you the freedom to do this. You get negative of pi over x to the pi plus 1. Remember, this x to the negative whatever is just 1 over x to the positive same that whatever, okay? So x to the negative thingamabob is 1 over x to that positive thingamabob, okay? Now, if I stick a negative out in front, then negative pi is going to come down here and bump into negative 1 multiplicative, and you'll get positive pi, and then you'll get the neg pi minus 1 up here, and then you'll do the same stuff, except you won't have that minus sign this time. Remember, if the derivative of f of x gives you one thing, the derivative of negative f of x will give you the negation of that thing. Okay. But anyway, and there's that, and let's see, if I do d by, and I'll leave it for you to do this one and this one. Again, if I stick 7 out in front, it's the same concept. The negative pi jumps out in front. I go ahead and just stick this negative. Instead of keeping the negative with the pi, I just stick it out in front of the 7, and I do the same old stuff. And here, I just do the same old stuff. And here, that 8 and that 5 can come out as 8/5, but otherwise I do the same old stuff. And I'll leave it for you to do this one. And then, well, down here, right here, the 2e just jumps down, and you'll get x to the 2e minus 1. You just decrement 1, guys. That's all, and bring the original guy down. And then here, the 2e jumps out in front. Now, by associativity, 2 times 6 is 12. So it's 12e times x to the 2e minus 1. And then if I have a negative 2 up here, the negative 2e just jumps down, and I get neg 2e minus 1. But remember, that can be thought of, this negative out in front just sticks out to the side. Now, remember, you can take out this negative and put parentheses 2e plus 1, and that comes down like that. Okay? Because you can filter out that negative 1 and put a parenthesis and put 2e plus 1 inside the parentheses. Okay? Because this exponent is the dead negation of this exponent. Okay? And then, now if I stick a negative half out in front and I have a negative 2 here, that negative 2e is going to bump into this negative 1/2. Now, associativity, that negative 2 and negative half are going to bump into each other and cancel to 1. So you're just left with that e times x to neg 2e minus 1, which again is e over x to the 2e plus 1. Okay, and likewise, 3/2. Now again, that negative 2e bumps into 3/2, but that negative 2 and that 2 down there cancel and make neg 1. Negative 1 times that 3 is negative 3. So I get negative 3e x to this power, which again, this negative right here sticks out in front as this guy right here. And then you get negative 3e over x to the 2e plus 1. And then in a similar fashion, what if I have 64 down here? Well, if 2 is understood to be, that 2 can multiply into that 3 up here and give you 6 over 64. And that negative that was with that 2 just sticks out here when I brought it down. And then, now you can reduce 6 over 64 to 3 over 32 and just do your usual stuff there. Because 2 times 3 over 64 is 6 over 64, which is 3 over 32, okay? You multiply, when you do like 3 over 64 times 2, you multiply the 2 with the 3 to get the 6 there. So I'll leave it for you to do these. And guys, I'm about out of time. Let me stop the video. Thank you.